Please look at your notes from yesterday that we started. We put down 4 steps yesterday to find the inverse of a function. Does anybody remember what step number 1 was? Looking at your notes. Okay, so we're going to replace f of x or g of x, whatever it happens to be, with y. What is step number 2? Switch x and y. Step number 3? Solve for y. And step number 4? Rewrite in inverse notation. So if you were gone or you didn't write that down, please write down those 4 steps. We're going to start off with some pretty easy problems, and then we'll definitely get more difficult here. So we're going to start with, there's only 2 concepts I want you to go over today. When we come back in tomorrow, we're going to talk about what do inverse functions look like on a graph. But our first learning objective is to find the inverse of a function. So f of x equals x to the 7th. So the very first step is to rewrite this with replacing a y instead of a f of x. Second step is to switch the x and y. Third step is to solve for y. So if we want to solve for y, we need to isolate it. That means we need to cancel out or get rid of this 7. So to get rid of it, I'm going to raise it to the power of 1/7. By doing that, the 7 and the 1/7 are going to cancel out and actually become 1s. And y equals x raised to the 1/7. Just as a little reminder from last unit, this is a rational exponent, so you could also write it in this form and it would be correct. The fourth and final step is to rewrite this in inverse function notation. So look up to the original, we're working with an f. This little -1 denotes that it's an inverse of function f, inverse of function f. And whether you write it in rational exponent form or radical exponent form, it does not matter. Problem is done. This is the inverse of the original function f of x equals x to the 7th. So I started with a pretty simple problem. Can you raise your hands right now if you understood the steps I took to solve for the inverse? Okay, let's do one that's just a little more complex. So same steps continuously. First step is I'm going to rewrite the function with variables x and y. Second step is I'm going to switch the x and y. And the third step is we're going to solve for y. We need to isolate it. So students had some confusion today when I was doing this particular problem. So they didn't know, do you first get rid of the cube root or do you get rid of the 10? And the answer is to get rid of the 10. First we want to get this radical by itself, and then we could take apart and get rid of the exponent. So to get rid of this 10, realize that this is really like a 1/10. This is really like a hidden 1/10. So to get rid of 1/10, you're going to multiply by the reciprocal, which is 10/1. The 10's cancel out, becoming 1s, and you have the cube root of 100y is equal to 10x. And you could write 10x/1, that would be fine too. Okay, to continue to get rid of the cube root and the 100, we're going to raise this to an exponent of 3. The 3 and the cube root, because this is really to the 1/3. So 1/3 and 3 are going to cancel out or become 1s. And when you apply this cube to both the 10 and to the x, you get 1,000 x cubed, because 10 cubed is 1,000, x cubed is obviously still x cubed. What number is hidden here? Well, here's the problem. See how this is a 2, but see how I had a 3 here and it belonged to the cube, root, this radical? When I cancel these numbers, I should also cancel out this radical. So this really should just be 100y equals 1,000 x cubed. That was a common mistake I saw students make in previous hours. When you cancel out the 3's, you also have to cancel out the radical. It goes along with it. To isolate the y, divide by 100. And 1,000 divided by 100, well, I can cancel out a 0 for a 0, and you'd be left with 10x cubed. This original problem had an h, so in inverse notation, it'd be h with a little -1, representing that it is the inverse of the original function h of x, equals 10x cubed. Turn to your partner and make sure you both are understanding real quick. Please do that. Tough problem. Okay, so here's how the next problem is going to work. I don't want you to look up on the board after you write down the problem. So let's start by first writing it down. This is going to be g of x equals 3/5 x cubed minus 9. So that's the problem. Now with your partner, I don't want you to work through it, not by yourself, but with your partner. And then if you get stuck, I want you to look up on the board because I'm going to do it at the same time. Or when you finish, I want you to check to see, do you have the same inverse? Okay, you guys ready? So I should hear you talking with your partner. Ready, get set, begin. Cardinal? Cortez?
The only thing I didn't do was distribute the fraction.
Okay, distribute the fraction, yep. Cortez, which part are you a little confused about that I can help you with?
I was tired of it.
To look back at the steps, what I did? Okay. Kalal or Brian, is there any part you'd like me to explain? Are you feeling confused, Brian? That's totally fine. Okay, you ready? Did you attempt it originally? Okay, so the first part is, let's go through it and go together then. So the first part is you switch the x and y. You got that part, right? Then we're going to isolate the y by first getting rid of a negative 9. So I'm going to add 9 to both sides. I'll zoom in so everybody can see. So on the left side we have x plus 9, and on the right side we have 2/5 y cubed. Just to make it a little bit easier, I'm going to work through it at the same time that I talk. So here's where we are right now. We've canceled out the negative 9 on the right hand side. So now I need to get rid of this fraction. To get rid of a fraction that's stuck with the variable, we're going to multiply both sides by the reciprocal. Reciprocal being 5/3. The 3's cancel and the 5's cancel. Reminder is when you cancel, you're really left with 1. So I have y to the third, and I'm going to distribute this. So 5/3 times x is 5/3 x. And when I multiply it times the 9, remember the 5 only gets multiplied by the 9, and the 3 gets multiplied by this hidden 1. So 5 times 9 is 45. 3 times 1 is 3. You can't see that. There we go. 5/3 does not reduce, but 45 over 3 does reduce to 15. By raise of hands, who's understanding up to this point now that I'm explaining? Okay. Now to get rid of the cube, we're going to raise it to the cube root or the 1/3 power. 3's and 1/3 cancel. And this is my answer for the inverse of the original function. Now I came back here and I rewrote it in inverse notation. G was our original function, and I put it both forms. This is if there's a rational exponent, and here is in the radical exponent form. Either one is okay, I just want you to recognize that they are equivalent. Okay? Let's do a simpler one. This one's going to be timed on your own. You're going to have a minute and a half, and then we're going to move on to the last learning objective for today. So we're going to simplify this one a little bit. See if you can do it without your partner's help, and I will definitely go back over it with you. K of x equals 3x to the 4th power. Begin. Miss Navarro, you forgot a black notebook over. Okay, you're good? Okay, great. $45 seconds remaining. If both you and your partner are done while we have the last 20 seconds, check with your partner to see if you have the same answer, please. Okay, so let me begin here. First, I'm going to replace k of x with y. Then I'm going to switch the x and the y. And do I first divide by 3 or do I raise this to the 1/4 power? Does anybody know what to do first? If you don't know, I want to tell you. So PEMDAS is parentheses, exponents, multiply, divide, and add, subtract. Do you guys agree? When you actually solve problems like this and you're working backwards, you're going to start with first getting rid of anything that adds or subtracts, then get rid of anything that's multiplying or dividing, then do the exponents, okay? You're going to work backwards. So first we're going to divide. So x over 3 equals y to the 4th. Then I'm going to raise both sides to the 1/4 power. And I have y equals x over 3 raised to the 1/4. I'll rewrite it in inverse notation. So k to the -1. If I write it in rational exponent form, it looks like this. And if I write it in radical form, it looks like this. Either one is correct. You don't have to put both down. Yes, Carlos?
I did like the opposite, but still got the same answer.
You did the opposite, so what'd you do?
I did the exponent first and then divided.
So you actually did not get the right answer, Carlos, but that's a great point you made. So first you raise to the 1/4. Maybe Maddie B can help you with this, okay? Here, your friend. Anyway, so you're going to raise this to the 1/4, right?
Yeah.
Okay, let me go back and say that. You think you got the right answer, but you actually made a math mistake. So you raise it to the 1/4 and you have this, correct?
Right.
That right now only applies to the x. So when your final step of dividing by 3 is, that 3, the way you did it, would be all by itself, and it would not contain the 1/4 as a power.
Okay, so I shouldn't have put both together, correct?
Right, yeah.
Well, I would have still gotten the point unclear. So.
Not if I checked your work. All right. Okay, so we're going to go on to your last learning objective for today. I need one person for each group to grab a paper for both you and your partner first. Keep your notes out. We're going to do one problem of notes, one problem of homework, and you're on your own. You spend a lot of time on your hair in the morning, Cortez? You don't? You blow dry it, don't you? Just to give it extra volume. Okay, so we're going to get going with this, so you have the opportunity to get your homework done in class. So here's the problem we are going to work on. You're back to your notes. This is our next learning objective. Back in geometry, there was a point where you had to prove different theorems. You remember doing proofs? Well, this is like a proof in algebra, but it's not going to involve words. It's going to involve math. So what we want to do is we want to verify or prove, this is our last learning objective, that the inverse of f of x is equal to g of x, and that the inverse of g of x is equal to f of x. So here's how we do it. Exact same methods we've been using. So first I make this a y equals 1/6 x to the 5th plus 2/3. Then I switch the x and y. There's no changes in your procedures. And now I'm going to solve for y. So just like I talked about doing PEMDAS and coming up from the bottom, so we start by getting rid of whatever's being added or subtracted first. So I'm going to get rid of the positive 2/3 by subtracting. So I've taken care of adding and subtracting. Now I'm going to get rid of what's being multiplied. So to get rid of the fraction 1/6, I'm going to multiply by the reciprocal. The 1 and the 6's on the right-hand side will cancel out. On the left-hand side, I'm going to take it just a little bit slower. So I have 6 over 1 times x. So I get 6x. Bring down the subtraction sign. 6 times 2 is 12. 1 times 3 is 3. So 6 divided by 3 is 4. Very last step, to get rid of power to the 5, or exponent of 5, we're going to raise it to the 1/5 power. and leaving it in rational exponent form, there's our answer. So the inverse of f of x is 6x minus 4 to the 1/5 power. As a reminder, if you wrote that in radical form, it would be 6x minus 4 with a 5 out front. These are equivalent forms. So the first thing is look at this answer. In either form, are they equivalent to what we have for g of x? So I'm drawing an arrow. That works. They both have to work if it's going to be, if you're going to verify that the two pairs of functions are inverses of one another. Okay, going to do the exact same concept here. I'm going to replace the g of x with a y. Then I'm going to switch the x and y. Now to isolate or solve for y, I'm going to raise both sides to the 5th power. The reason for that is this is really a 1/5. So how do you cancel out a 1/5? You raise it to the 5th power. In doing so, the radical will cancel. Add 4 to both sides. Divide by 6. 1 divided by 6 cannot be reduced. 1 divided by 6 cannot be reduced. 4 divided by 6 reduces to 2/3. This original problem was a g, so the inverse of function g would be 1/6 x to the 5th plus 2/3. I checked, and it is exactly what we had for f of x. So the question is, can we verify that these two are inverses? And the answer is yes, they are inverses. The pair of functions are inverses of one another. Okay, take out your homework. Please find problem number 1. Whether you like the word prove or verify, they're asking us to complete the second learning objective from today. I like to split this in 2 parts. First, I'm going to only focus on f of x. I'm going to find the inverse of f of x. So y equals 8x cubed. Switch x and y. Get rid of the 8 by dividing. Don't use Carlos's method.
I was literally about to say.
To get rid of the cube, raise it to the 1/3 power. So I have x to the 1/3 when I apply, and I have 8 to the 1/3. Well, 8 to the 1/3 means what number times itself 3 times equals 8? The answer is 2. Rewrite it in inverse notation. And then check, is it the same as the second equation? And it is. Okay, let's do the next one. Same concept, y equals x to the 1/3 over 2. Switch the x and y's. And this is a tougher concept for a lot of students. Remember, it's really like a 1/2. So to get rid of the 2 on the bottom, multiply by the reciprocal of 2 over 1, or 2. 2's and 1's cancel. To isolate the y, we're going to get rid of 1/3 by raising it to the 3rd power. Remember to distribute the 3 to both the 2 and the x. So 2 to the 3rd power, 2 times 2 times 2 is 8. X to the 3rd power is x cubed. I'm going to rewrite it in inverse notation. And then check to see, is this exactly of the other function? Yes, it is. We just verified that the two pair of functions are inverses of one another.